Hello everyone! It's time to learn math with Ma'am Liani. Are you ready? Then come on, join me and let's begin. In this lesson, I will be teaching you the slope of the line. Our objectives: you can understand the concept of slope of a line. You can find the slope of a line given different situations. And you can appreciate how the knowledge of slope is used in real life. Let's have a quick recall on the standard form of a line when we have linear equations in two variables. It's written as ax plus by equals c, where a, b, and c are real numbers, and the a and b are not zero. For example, we have 2x plus 3y equals 6 and 4x minus y equals 8. These are examples of linear equations in two variables written in the standard form, as the x and the y variables are written together in one side of the equation. So you can see that they are both written in one side of the equation. Okay, so that's the standard form of a line. Now we will go to the next form, which is what we call the slope-intercept form of a line. It is given as y equals mx plus b. The y here, as you can see, is by itself in one side of the equation, and the x variable and constant are together in the other side of the equation. So it's different from this standard form, as you can see. Okay, the y is written by itself, and the x and constant must be written on the other side of the equation. So that is the slope-intercept form of a line. Here, where the m is the coefficient of x, and that is equal to the slope of the given line. And the b, which is the constant, is the y-intercept. The y-intercept is defined as the point where the line crosses the y-axis. So if this is our linear line, the graph of a linear equations in two variables, this point is the y-intercept. It's because it is where the line is crossing the y or meeting the y-axis. Okay, they meet at this point. And that is the y-intercept. We will have more of this on our next video tutorials. Okay, in the meantime, our main lesson today is finding the slope of a line. Okay, example of, okay, there you are. That is the y-intercept. Example of an equation written in the slope-intercept form is y equals x minus 1. So our m here, the coefficient of x is 1, and our b, which is the y-intercept, is negative 1. So if you can see the graph here, that is below the origin, and our value of y is negative 1. Okay? Where can we encounter these slopes in everyday life? Here you can see slopes in this figure or picture. Here, staircase. You can also see slope in there. It represents slope. This mountain as well. And this hillside as well. So to represent the slope in these pictures, we draw a line along this inclination or along this path. We draw a line following this path. We draw a line over here. And these lines are inclined or slanting. Or in other words, they show the slope or steepness of a certain object or a certain place. So how do we define slope? Slope is the steepness of the line. It is also commonly known as rise over run. We can calculate slope by dividing the change in the y value between 2 points over the change in the x value. So we normally represent these slopey figures using straight lines. And that's when the linear equations in two variables come in. And when we talk about lines, we also talk about points on the line. So when we divide the change in the y value between 2 points on the line over the change in the x value from these same 2 points, then we will be able to solve the measure of the slope. That's what we're going to do in this lesson. Okay. So the slope of a line is the ratio of the vertical change between 2 points to the horizontal change between the same 2 points. And we use a formula for that. M, which stands for slope, is equal to the vertical change over the horizontal change. The vertical change is commonly known as the rise, and horizontal change is known as the run. Let's take a look at the first example or first case. Okay, finding the slope of a line given 2 points on the line. Example 1. What is the slope of the line that passes through point A with coordinates 2, 3 and point E with coordinates 1, -2? So point A is given here in the figure, in the graph, and point E is down here. And you have the ordered pairs representing them, or their coordinates. So if you know these 2 points with their coordinates, this is the method for us to solve the slope. Okay. Say, for example, this friend here is trying to climb up this very steep mountain. Now, what is the measurement of the slope of this mountain represented by this line? Okay, we know by definition that slope is the rise over run, or the vertical change over horizontal change. Now, how do we know the vertical change? We will find the difference between the y coordinates of these 2 points, and we divide that by the difference between the x coordinates of these same 2 points. Okay, for example, okay, this is the distance that you can see between the 2 points along the vertical. This is the vertical change. So we will find this distance between them. And how do we do that? We will use this formula. M equals, or slope, or M is equal to y sub 2 minus y sub 1. This refers to the difference between the y coordinates. And we divide that by the difference between the x coordinates. That will be represented by this distance. Okay, so when we talk about x coordinates, is measured along the x-axis. So this is the horizontal change, the horizontal distance. Okay, ito naman yung vertical distance, showing us the change in position. So from here, it went up there. So from there, it goes down here. So this is the horizontal or vertical change. Okay, and this is the horizontal change, which we can get using the formula of a slope, as long as we are given the 2 points. Now let's say this is our first point, and this is our x sub 1. And this is our y sub 1. This is our second point. Okay, x sub 2 is here and y sub 2 is there. And now we are ready to substitute in our formula. Okay, let's write the y sub 2 first, which is -2 minus 3. Okay, write it down. -2 minus 3 over the x, a difference between the x coordinates, which is x sub 2 minus x sub 1. That is 1 minus 2. 1 minus 2. And then you simplify. -2 minus 3 is -5 over 1 minus 2 is -1, giving us the slope of +5. So if you look at the sign of our slope, it is positive. And if you look at the direction of our line, it's slanting upward to the right. Okay? So it's kind of telling us that when we have a positive slope, the line or the graph of the line is slanting from left to right upwards. Okay. Okay. More examples. Let's find the slope of the line given the equations below. Y equals 3x. In this example, we don't have a constant. Well, that's okay as long as we have the two variables in the equation. And this is also written in the slope-intercept form because the y is separated from the x variable. Okay? Applying our given method, m is the coefficient of x. Therefore, our slope here is m equals 3. All right? Next, y equals negative 5x. So in this case, our m, which is the coefficient of x, is our slope. And it is negative 5. How about number 3? I think you will be able to give me the answer in this question. Okay. If your slope is 4, then your answer is correct. Number 4. Your guess is right. M is negative 4. And how about number 5? What will be our slope? Okay, in this case, you cannot apply this method, class, that we are using. Why? Because this is written in the standard form. The equation is not written in the slope-intercept form. So what shall we do if it's like this? We have to rewrite this or convert this into the slope-intercept form. And this is the method. Let's rewrite this 2x plus y equals 4, which is in the standard form, into the slope-intercept form. That is y equals mx plus b. So to do that, we eliminate the 2x so that we will solve for y, and y will be by itself on this side of the equation. And we will apply addition property of equality. We can add, okay, from this original equation, we add negative 2x to the left side and to the right side of the equation. So this 2x minus 2x will be eliminated. That becomes 0. What is left here? Y equals negative 2x plus 4. There. We now have rewritten this linear equation into the slope-intercept form. And we are now able to find quickly the slope of the line. Okay? So using our pattern or our slope-intercept form, our m, which is negative 2, will be the slope of this line. Okay? So that's for finding the slope of a line given the equation. Now, let's move to the other case. Case 3. Let's find the slope of a line given us the graph this time. All right? So, this is now applying our formula, slope equals rise over run. Okay, given us the graph, we can easily find the slope using our concept of rise over run. So this is our line, and we locate or select 2 points along the line. Okay, it's already given to us in here. Now, going to the solution, the first step will be, we select one of these points and count convenient units to the right or to the left, depending on the position of the second point. This will be our run. So in this case, okay, starting from this point, we will move to the right because our second point is on the right. So we move to the right and we'll count how many units. We have 1, 2, and 3. It's 3 units to the right. Okay. And then to go to the point, the second point, we will count the number of units vertically up or vertically down. until it meets the line at the second point. And this will be our rise. Okay, so in this case, from this point, we will move vertically up because the second point is here. So if the point is down here, we will move vertically down. Okay, and how many units, how many chains in our vertical position? We have 3 units going up. The horizontal chains is 3 units to the right. And now with this information, you can solve for the slope. Okay, the rise over run will be, okay, the rise is 3 units and the run is also 3 units. Therefore, our slope is positive 1. Okay, so that's how we apply the formula rise over run when the graph is given. The line is slanting upward to the right, you notice it, and it has a positive slope. Okay, it confirms our previous example that slants to the right. The slope is positive. Next. Okay, still we have the graph given to us. Let's find the slope applying our formula, rise over run. So let's select 2 points from here. Okay, so the solution now, we'll select 2 points, say from here and here. Going to the steps, choose from any of these 2 points, select a point and count convenient units to the right or to the left. Okay, so let's start from here, from this point, and we will move to the left because our second point is at the left of the first point. So let's move to the left. How many units? 2 units to the left. That means that we will give a sign of negative to this run. This is our run, horizontal chains. And what about our vertical chains? We will count the number of units vertically up this time, vertically up, because our second point is there. So how many units? That's 4 units up. It's going up. That means we will give a sign of positive. Okay. Now with this, we can solve for the slope. M equals, our rise is 4 units up, so it's positive 4. Our run is 2 units to the left, so we give a sign of negative 2. Okay. The movement indicates the sign of your run units and rise units. So simplifying, our slope is equal to negative 2. And you will notice that the line here is slanting downward to the right. Okay, if you start from the left, it slants downward. It's kind of downhill. Okay, and it has a negative slope. So this confirms our previous example having negative slope. They are slanting downward to the right. Okay, next. There you go, comparing these 2 different slopes. We have all lines slanting upward to the right have positive slope. Okay, and all lines slanting downward to the right have negative slope. Okay. So you have a way to check whether you are on the right track depending on the graph of the line. Whenever you are solving the value of the slope. Okay. Oh, additional example under case 3. Still using a given graph, let's find the slope. This time it's different. Okay, the line is flat. It's parallel to our x-axis. So this is our x, and if the line is here or anywhere that is flat and parallel to the x-axis, how do we solve this slope? Oh, well, we will use the same concept or formula. Okay, so we'll go to the solution. Let's choose 2 points here. There you go. We have 2 points. Then we will apply, of course, the steps. Select 1 point and count convenient units to the right. So say we will start from left to right. Okay, from left to right, we count how many units? 1, 2, 3. So it's 3 units to the right. Pwede rin ba, ma'am? Right to left? Pwede rin. Okay? It's okay. Doesn't matter. You may start from the point here, going to the right, or right to the left. Okay, your answer will still be the same. Okay, if we go to the second step, we count the vertical chains, or we will count the number of units vertically up. So we went from the first to the second point, and we are already on the second point. We don't have to move anymore. We cannot move anymore upward or downward because we have reached the second point already. Therefore, we don't have any rise in here. So how do we solve if that's the case? It's like this. Okay, no rise, no vertically chains. So we write 0. And our run, the horizontal chains, is 3 units. So 0 divided by 3 is equal to a slope of 0. Okay? So you can conclude that the slope of any horizontal line, any line that is parallel to the x-axis, is 0. All right? Now, what about if the line is, say the line is, or the graph is something like this. It is a line that is parallel to the y-axis this time. It is a vertical line, parallel to the y-axis. A while ago, we have a horizontal line in the previous example. Now, how do we get the slope of this line? Well, let's find out here under our solution. Select 2 points once again. Okay, and then we will count the units along the run. Okay, along the run, well, where shall we start? Maybe we'll start from any, from here. O dito tayo mag-start. Okay. If I move to the right, I don't have a way to go to the second point. If I move to the left, there's no way for me to go to the second point. So in this case, there is no movement along the run, meaning our run units, our run here will be 0. Okay, we can only move vertically up or down. So if you can see this, to go to the second point, you can only move downwards, vertically down. So walang movement dito sa horizontal. Ang movement lang natin ay vertical, downwards in this case, because we started from this point. Now, how do you solve the slope for this kind of graph? It's 4 units down. So kung ganon, our slope, which is rise over run, we don't have any run, but our rise is 4 units. We have a -4. Negative because its direction is downward. Now, paano man pag mag-umpisa ka sa baba tapos pataas? Eh di positive ang ilagay mo, but then the answer will still be the same. It doesn't matter. The answer will still be the same because m equals -4/0. And if we are dividing by 0, ano yung sagot natin? Yes, undefined ang sagot natin dyan. So whenever a line is vertical or parallel to the y-axis, the slope of all vertical lines are undefined. Wala tayong ma-solve na slope niyan. Take note of that. If the line is here, still, kahit saang dyan, position, basta vertical yung line natin, ang slope niya ay undefined. Okay? So, to sum it up, the slope of a line is constant throughout any segment on the line. Okay? It's always a constant. Andito man yung points, the slope is the same. whether you are up here or down here or somewhere here, parehas lang yung mga values ng slope. Kung nasa middle point ang napili mong points, parehas lang yung mga slope anywhere along this line. That's why it is constant. It does not change wherever point you solve the value of the slope. All right. If the line slants upward to the right, the slope is, of course, positive. Okay. If the line slants downward to the right, downward, our slope is negative. And if the line is parallel to the x-axis, this line is parallel to the x-axis, our slope is 0. Okay. And if the line is parallel to the y-axis, this vertical line, okay, all of these kind of lines have undefined slope, or there is no slope. All right. So that's to sum up all our lessons about the slopes of lines.